For problem number 2, we're asked to use the definition of the derivative to find the derivative of f of x equals x squared minus 3x plus 1. So on the exam, you will only get credit if you use the definition of the derivative like we discussed in section 2.6. So first I'm going to write out the derivative. That's f prime of x is equal to, and important here that we write the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we're looking for the limit as h approaches 0. We're going to put in x plus h into our function. So the function f takes inputs in and squares them, and then does minus 3 times the input, and then adds 1. So for f of x plus h, we're going to put x plus h into the parentheses there. Then we are supposed to subtract off f of x, and what we said we want to be careful about is that we distribute that negative. So I'm going to put that negative out front of the parentheses for f of x, and then we're going to divide by h. We're going to square x plus h, and x plus h squared would be x squared plus 2xh plus h squared. Distribute our negative 3, so that's negative 3x minus 3h. Bring down the plus 1. Then we're going to distribute the negative into the parentheses for f of x, so that's minus x squared plus 3x minus 1. And of course all of this is still divided by h. Now we're going to cancel like terms. So I'm going to cancel out x squared with minus x squared. Minus 3x cancels with plus 3x. Plus 1 cancels with minus 1. So that leaves us with the limit as h approaches 0 of 2xh plus h squared, and then minus 3h all over h. We're going to cancel out the common factor of h throughout the problem. And then when we do that, we're going to be left with 2x plus h and then minus 3. Remember, there's a couple of different ways you can do that. You can take each term and divide by h, or you can factor out an h from the top group, so that would be left with 2x plus h minus 3, and then divide out those common factors of h. So either way you choose to do it, you will be left with those three terms. And remember that we're looking for the limit as h approaches 0 of those three terms. So we're going to plug in our h value of 0 into those terms. So we get 2x plus 0 minus 3. So the derivative would be 2x minus 3.